The universe is a vast and mysterious realm teeming with cosmic marvels and mind-bending anomalies. Among the most extreme and enigmatic entities in existence are black holes and magnetars. A black hole is an unfathomably dense region of space where gravity is so overpowering that nothing, not even light itself, can escape its pull. These cosmic voids arise when massive stars exhaust their nuclear fuel and collapse under their immense gravity, creating a singularity and infinitely dense point encased by an event horizon, the threshold beyond which escape is physically impossible. Meanwhile, magnetars represent an entirely different breed of celestial powerhouse. These exotic neutron stars, born from the explosive death of massive stars in spectacular supernovae, possess magnetic fields of unfathomable strength, trillions of times more intense than Earth's. This magnetic fury makes them some of the most extreme objects in the cosmos, capable of releasing bursts of energy so powerful they can disrupt satellites and communications on Earth from thousands of light years away. Imagine a scenario where one of these magnetars drifts too close to a black hole. The result would be a cataclysmic event unlike anything humanity has ever witnessed. As the magnetar approaches the black hole, its intense magnetic field would begin to interact with the immense gravitational pull of the black hole. This interaction would create unimaginable distortions in spacetime, generating immense tidal forces that stretch and compress matter violently. The gravitational tug-of-war between these two celestial titans would unleash a storm of high-energy particles and radiation, creating a dazzling cosmic light show that could be detected across vast distances. As the magnetic field of the magnetar intertwines with the immense gravity of the black hole, powerful bursts of gamma radiation would erupt from the chaos. These bursts, the most energetic form of electromagnetic waves in existence, could outshine entire galaxies for a brief moment. Magnetic reconnection events, sudden shifts in magnetic fields could release energy equivalent to billions of nuclear explosions. The surrounding space would be bathed in an inferno of X-rays and radio waves, signaling the violent demise of the magnetar. But despite its immense power, the magnetar would ultimately be no match for the monstrous pull of the black hole. Slowly but surely, the relentless gravitational force would begin to stretch and distort the magnetar, a process known as spaghettification, turning the once mighty celestial body into a thin stream of stellar material spiraling into oblivion. Over time, the magnetar would be torn apart, its material spiraling into the black hole's accretion disk, a swirling mass of superheated gas and dust that feeds the singularity. As the magnetar is devoured, it would unleash gravitational waves, ripples in the fabric of spacetime that travel across the universe at the speed of light. These waves, if detected by instruments such as LIGO or Virgo, could provide valuable insights into the nature of these extreme cosmic objects, offering a rare glimpse into the violent interactions of some of the most enigmatic entities in the cosmos. As the gravitational forces continue their relentless pull, the magnetar's remaining matter would undergo extreme compression, its atoms shredded apart into subatomic particles before ultimately disappearing into the event horizon. The energy released during this process would be immense, creating a brief but spectacular surge of radiation visible across enormous cosmic distances. This immense release of energy would further fuel the surrounding accretion disk, causing an increase in high-energy emissions detectable by telescopes designed to observe X-rays and gamma rays. Once the black hole has consumed the magnetar, it would grow in size and mass, expanding its event horizon and becoming an even more formidable force in the universe. This newly acquired mass would slightly alter the black hole's gravitational influence, subtly disturbing the orbits of nearby celestial bodies and potentially setting off chain reactions of cosmic events. With each new object it absorbs, the black hole strengthens, continuing its endless feast on the cosmos. Over the course of millions or even billions of years, the region around it may become a graveyard of fallen stars, a testament to the insatiable hunger of these cosmic behemoths. The universe, in its infinite complexity, continues its cycle of destruction and rebirth, shaping the very fabric of existence itself. This hypothetical scenario serves as a reminder of the sheer power and scale of the universe, a realm where the most extreme forces dictate the fate of celestial bodies. It also raises profound questions about the destiny of our own galaxy. Could a similar event one day threaten the Milky Way, altering its structure in ways beyond our understanding? While such an occurrence is highly unlikely within the brief timescale of human existence, it remains a fascinating possibility that underscores the unpredictable nature of the cosmos. The universe is in a constant state of flux, where destruction and creation exist in an endless cycle, forging new worlds from the remnants of the old. This dynamic interplay of forces has shaped the cosmos for billions of years and will continue long after humanity has ceased to exist. As we gaze into the night sky, we witness a universe filled with both beauty and chaos, where the most powerful phenomena unfold on incomprehensible scales. From the birth of stars to the collapse of entire galaxies, the intricate ballet of cosmic events serves as a testament to the relentless forces at play. The violent collisions of black holes, the explosion of supernovae, and the gravitational ripples spreading across spacetime all contribute to the grand evolutionary process of the universe. These cataclysmic interactions are not just destructive, they are also fundamental to the formation of new celestial structures, shaping the galaxies we see today. While humanity may never directly witness an event as catastrophic as a magnetar being consumed by a black hole, the study of such theoretical scenarios provides valuable insights into the fundamental workings of the universe. The more we uncover about these powerful cosmic events, the closer we come to understanding the intricate web of forces that govern reality itself. The universe is an ever-changing tapestry of unimaginable power and profound mystery, where each event, no matter how violent, plays a crucial role in the grand design of existence.